So this is kind of reviewing the things that were requested for our review. And if there's more things that you guys want to add, feel free and we will talk about that. So I think I'll leave it in the window that it is. So for number 4, we're talking about your first sheet, the one that you're going to need for tomorrow. Okay, so if there's, pretty much this is the one you're going to need to study. So just study this for tonight. So again, that's going to be your the 11 question study guide that you should be looking at. So if we have an equation that we're going to write, it's going to go through -2, 5, and it is going to be parallel. So I'm going to make a little parallel symbol. And then 2x plus 3y equals 17. So there is a reason. This is the old line. I want to create a new line. So does anybody remember, what do I need from that line? The slope. Does anybody remember? Thank you. How do I find the slope of that? Couple approaches. Number 1, I can either solve it for y, or I can do that little code of -a/b. So I like to do the code because to me it's shorter and I just need the slope. I don't need the slope and the y-intercept. So the code is -a/b. This is the number in the a spot. This is the number in the b spot. So my slope is going to be -2/3. And so that's all I need from that equation and nothing else. So this is my slope. Now I've got my ordered pair, and I really like point slope. It's one of my favorites just because it's so easy to write with. And so the formula for that, again, is y minus y1 equals m parentheses x minus x1. And so therefore, now the y1 and the x1 are the plug-in spots, and then the slope, of course, is going to be the slope that we have. So we're going to have y minus, now I got to refer to my lovely coordinate. So my y is 5. Now, since it says parallel, I'm going to use the -2/3. Okay, what do you remember about parallel lines and their slopes again? They're the same. What if I said perpendicular, though? What would we do? Right, so then it would become +3/2. But I said parallel, okay? And on the test, I believe I put parallel as well. So therefore, I'm going to need the slope, which is -2/3. And then x minus my x coordinate, which is -2, which is going to make that switch to a plus. Okay, everybody okay with where I plugged and chugged and stuff in? Then I'm going to distribute. So y minus 5 equals -2/3 x, and then -2/3 times 2 will make -4/3. And then I'm going to add 5. So y equals -2/3 x, and this is really -1 1/3, so I'm really taking 5 minus 1 1/3, so that's going to give me a +3 2/3. And that's my equation. That's it. So nothing else to do with that one. Is that okay? Anybody want another example of that, or yay, nay? Okay. So there's that one. Okay, 4.8. This one just said write the appropriate constraints in the objective function, and then let's talk about what it's going to look like on the test, because it's going to look slightly different on the test. So on the test, I'm going to give you a graph. And remember, I don't know if you remember, what do you remember about linear programming? So do you remember we had all these like inequalities, and then what happened? What did we use? Then we would always go on Desmos, and then we would find the shaded region. Okay, so in number 8, what we're doing is we're looking at, we need to define the variables. So the problem again is talking about that you're having different dance classes 7 days a week, all hours of the day, maximizing profit. And so she can offer at most 8 tap dances and 5 jazz classes. And again, because of the limited classroom space, she can only have as many 10 classes per day. And the studio makes $160 profit on the tap and $250 on the jazz. So I'm hoping with that you could come up with the constraints. So I use T and J. So T is going to stand for tap. Okay. On the test, you will have the constraints. Okay, so don't freak out. So we have T is less than or equal to, and then tap, I couldn't have any more than 8. So 8 or less. And then for jazz, I couldn't have any more than 5. And then tap plus jazz is less than or equal to 10. That would have been my constraints. And then the profit, so when you do your profit function, that's how much money do I make off of a tap class and how much money I make off a jazz class. So then I'm going to have 180 T plus 250 J. Everybody okay so far? All right. Now, I'm not expecting you on the test tomorrow to go upload Desmos. Okay? So on yours that you're going to do on your final, you're going to have the inequalities, and I'm going to give you the region. Okay? So let's take a look at what this region would look like. Okay? So with this region, I'm going to quick fire up Desmos here. And of course, Desmos cannot work with T's and J's. So my T is gonna be X and my J is gonna be Y. So therefore, we're gonna have X, and that is going to be less than or equal to 8. And then I don't know if you guys remember, we also had hidden constraints. Like for example, could I have a negative number of jazz dance classes? So remember how there were 2 hidden constraints that we also could have X is greater than or equal to 0, and then Y was greater than or equal to 0. And that basically put it in the first quadrant, if you guys remember. And then we also have our X plus Y is less than or equal to 10. So I'm trying to look for where all my colors merge. I hate that color black and stuff like that. I think there's a way to change it, but it doesn't always want to do it. I don't know if I want a green. That might be a little better. Is that better than the black? Okay. So anyways, so with this, what I would do then is on the test, you're going to have this region. And you should be able to clearly see that region. And you're going to see some ordered pairs. So like right now, I know that this is where my region's going to be. Okay, so you'll see a picture that looks like that. Now, do you remember what to do with these lovely things? We're going to plug them into our profit statement. Okay, so I'm just going to jot them down on my sideboard here so I can show you what we'll do after that. So 0, 0, 0, 0, 5, 8, 0, 8, 2. Okay. So anyway, so you'll have the graph. So you'll have the inequalities on the final for this question, and you're going to have the profit statement, and you're going to have the picture. So your job then is just to, so it might say, what are the critical points? And then you'd say, oh, my critical points are da-da-da-da-da-da-da-da-da. So our critical points again, so I'm just going to go right to a table here. So I have 0, 5. I don't know why I made 2 of them, but whatever. 5, 5. Why did I do it that way? I don't like that. Let's do it this way. So 0, 5, 0, 0, 5, 5, 8, 0, and 8, 2. And then you just plug it into your profit. Well, we know 0, 0 is just going to be a whole whopping 0. And then this one will do 250 times 5. Okay. And so therefore, let's see, what would we have? That sound right? 250 times 5? Okay, and then 5 times 5, or 5, 5. So then I would have 160 times 5. And then I'm going to add that 1250 on because we already know that 5 times 250 is that. So 160 times 5 is 800. 800 added to this is going to give me 2050. Then if I did 80, so that's 160 times 8. That's going to give me 1280. And then finally with the 82, that's going to be 1280 plus $500 more. and that's 1780. So where would we get the max profit? So what would be our final answer? So you'll need to be able to figure that out. So we should have 5 of each. So then we say you need to have, so remember how we used to write a sentence for that? So we need 5 tap classes and 5 jazz classes for a total profit of $20.50. Do you remember some of this stuff now, back in the day? Yeah? So, but at least be happy, number 1. Do you have to come up with the inequalities? That was the hard part, remember? And then number 2, you don't have to graph it. So really, you're just kind of applying it. Because on the ACT, that's what you would see. You won't have to do the whole problem. So did that help with 8? Kind of clarifying that a little bit? Okay, then the last one you guys wanted on the short answer part, and you're making me nervous. And then I lost my sheet. Where do I put my stuff? I swear to God. Here it is. All right, number 10 is talking about parent functions, and this was good old chapter 2. So that was that chapter. And so in chapter 2, we talked about parent functions. And so does anybody remember what is the parent function of an absolute value? What does that look like? Yeah, absolute value in an x. Remember, that's the parent function for absolute value, right? Okay. And then if I ask for what is the parent function of a quadratic? So f of x would equal x squared. Or if I wanted the parent function of a square root. You remember some of these? Because we were talking about how they're like different families and stuff like that. You know, there was a little song that went with it because they always are at the origin and stuff like that. And they have children that have similar traits and all that other fun stuff. So then for these parts, what you're supposed to do is write an equation that represents the words and what we have. So it says you want an absolute value equation where it's going to shift up 5 and horizontal shift right 3. So hopefully, I don't know if you remember, but if it's going to change horizontally, that goes inside with the x value. So it doesn't matter what parent function it is. So therefore, for this one, because it's saying it's going to the right, we learned that that was x minus 3, because remember how the middle couldn't be trusted? And then it was going to move it up 5 with a vertical shift. And remember, we could trust this number. So that's going to be the equation. So again, in this particular, and this works for all the families, is that if this is negative, it's going to the right. If it's positive, then it's going to the left. And then remember, if this is a plus 5, it's going up. And if this is negative 5, then we're going down. And so that's kind of what we're doing with that. So for part B, it's saying, okay, give me a square root with a vertical compression. So what that means is it's shrinking. And so since it's shrinking, that's when the number in front of the parent function is that fraction. So if it's smaller than, if it's between 0 and 1, remember we talked about how that's going to compress the function, it's going to shrink it. If this was like a regular number, then that would be different. It wouldn't be a compression, it would be a stretch. Remember we talked about stretching, compression, stretch. Okay, then for C, we have a cube that's reflected over the x-axis, vertical shift down 2. So again, it's a function. It's a cubic, so I know to start here. But if it's reflected over the axis, do you remember what we needed to add from the past? A negative sign. And then it's also going down, so I need a minus, and then a 2. And so that's what that function would look like. And then the last one says you have a quadratic with a vertical stretch of 5, horizontal shift of 8, and it says left. So to me, that tells me I'm putting the 5 in front of the x squared, and then, but since it's doing a horizontal shift, I got to put stuff in here now. And so since it's shifting to the left, it's actually going to be the opposite of what you think it is. So it's going to be x plus 8 quantity squared. Yes? Sure. Like if a stretch would be like 7 square root of x. Mm-hmm. So it'd just be like a regular number that's not a fraction. So like what if I said f of x is equal to negative 3 square root of x. So what does the minus do again? Reflection over the x-axis. Then don't worry about that minus now. The 3 will do that vertical stretch. And then, of course, it's a square root function. So yeah. And again, that middle value, again, is the opposite of what you think it is. So that middle value, again, if it's a plus, I'm actually going to the left. If it's minus, I'm actually going to go to the right. And then this one you can trust. It's what you see is what you get. So if it's positive, it's up. If it's negative, it's down. So, all right. Anything else from the study guide for tomorrow's test? Okay. All right. And everybody is okay on number 2 to check for extraneous values. Does everybody remember about extraneous values? Remember that means you plug it in, and if it doesn't work, then you get rid of it. Okay, so make sure that you do that with that. But if you guys are okay with that particular one, then I will switch to the next. Okay, so for the other study guide, that was more of just more general practice on some of these problems. So, and that matches more of the second part of the final. So, all right, so first we're going to go through some ands and ors. So that's going to cover that. And then we're going to go through a little bit of graphing and substitution and a little more graphing with piecewise. And then we're going to wrap it up with some lines. So, and then if there's anything else you guys want to talk about, we can. Otherwise, you guys can study. So, and how did tests go yesterday? Did you think it was okay? I made a few people upset with me, but overall it was a good day. So, people said they needed more time, but they didn't need more time. So anyway, so number 8. Okay, so here's the problem in number 8. Do you remember the difference between an and or an or? So you can use the wonderful Mr. Keller-ism that goes with, it's kind of like a Mr. Tesh-ism, but it's a Mr. Keller-ism. And so remember, if it's greater or greater than or equal to, it's a or, because remember I'm saying greater wrong on purpose, because it's just greater, but greater. And then if it's less than or equal to, less than sounds more like and. And so in this problem, it's an or. And so I'm going to write the 2 scenarios. So x minus 3 is greater than or equal to 4. That's the first scenario. It's an or. And then you rewrite the x minus 3 condition. But remember, it's not going to be 4. It's going to be negative 4. And since I'm doing that, in a way, I'm dividing by negative 1, which means I have to switch the inequality sign. And then from there, I'm going to solve it. So I'm going to add 3 both sides. Again, add 3 to this side. And then an or is pretty easy to graph. So if this was like 7, this is over here is negative 1, it'd have a closed dot color to the right, and then this would be a closed dot color to the left. So you go your way, I go mine. So that's what 8 would look like. And then for 9, 9 is a little bit different, not by much though. This time it's an and. So you're going to just have 2x minus 3 is less than 7, and 2x minus 3 is greater. So notice I flipped that sign. Whoops, not negative 3, negative 7. And then from there, just solve. So here I'd add 3 to get 2x is less than 10. So x is greater than, or probably x is less than 5. This one we're going to add 3. So we're going to get negative 4, divide by 2, x is greater than negative 2. And then remember, ands is where they we look for where they overlap. So 5 would have been an open dot, -2 would have been an open dot, and then where do they meet? They meet in the middle. So is that good? Crash course on that again? Okay. All right. So we got 8 and 9 taken care of with that. Okay, so 11, what we're doing on 11 is we are doing some elimination with this one, which would be my recommendation. And then did you know if you pick the right equation, you can actually get more than one letter to cancel? I don't know if anybody noticed that. So which two equations look the most alike that we could get more bang for our buck? We can get rid of 2 letters if we're smart. The top and the bottom. So I'm going to have 2x minus y plus 2z equals 15. I hate to subtract, so I'm going to multiply this equation on the bottom by -1. So I'm going to have -3x plus y minus 2z equals -18. Does everybody see that the y's and the z's will drop? So then I'm going to add these up. So I'm going to get -1x. And 15 plus -18 is -3. So when I divide by -1, I get x is 3. So remember, this is an x, y, and z. And so then the next thing we would want to do is probably find another way to get something to drop. So maybe let's look at the first 2 equations, because I can get the y's to drop there. So we're going to have 2x minus y plus 2z equals 15, and -x plus y plus z equals 3. And when I add, the y's will drop. So what I'll end up with is x plus 3z equals 18. But the reason that's cool is I know what x is. And so x is 3. So then I'm going to put a 3 in place, and then subtract 3. And then divide. And so I'll get z is 5. And then finally pick an equation that you want to do. So I'm going to have -3 plus, I'm going to do the middle one, y plus 5 equals 3. And so we're going to have 2 plus y equals 3. And therefore y would have to be 1. And there it is. So there's 11. So with that. For 12, we don't want to do 12 now? You want 16, no 12. Okay. So no 12, now 16. Got it. Okay. So we have 16 and 17. I wish I had a grid that went on my board, and I don't have such an animal. Used to back in the day. So I'll just have to graph it and hope for the best. So in 16, you have 2 inequalities that we're going to graph. This is like graphing a line, except that, remember, we're going to have dashed lines and solid lines. And then, of course, remember, we're going to do some shading. So the first thing I would do in both equations is I would solve for y. So that would be my first approach. So we're going to have 3y is less than or equal to -2x, because I moved the 2x over, minus 6, and then divide by 3. So y is less than or equal to -2/3 x, and then minus 2. So there's one inequality. The second one, I'd have a -y. Again, I'm going to move that 2x over, so it becomes -2x plus 4. But I have to divide, unfortunately, by -1 because I got a -y. And so that's going to make my inequality sign switch. So now I'm going to end up with positive 2x minus 4. So now I've got both of these. And then the next we're going to do is we're going to graph. So graph it out. And it's not going to look beautiful, but you'll survive. So on your test, you've got beautiful grids and stuff, and so things will work fine. And so the first one we're going to start at -2 on the y-axis. And then I'm going to go, down to right 3, or I could go up to left 3, and this is equal, so then this is going to be a solid line. Then from there, we have to test a region, and so what was our favorite checkpoint of all time? 0, 0, unless 0, 0 is on the line, then you can't pick 0, 0. So I would probably go back to the original equation because it's easier to plug in 0, 0 here. So we'll find out, is 0 going to be less than or equal to -6? No, that's false. So therefore, this side is false, so this side is true. So again, you always color what happens with your region with 0, 0. So if 0, 0 is true, color where the region where 0, 0 is. If it's false, then color the other side. Then the second inequality, we're going to start at -4, and then I'm going to go up to right 1. And then this one's going to be dashed. Why is this one dashed? It's not equal to, so that's why it's dashed. And again, I can pick 0, 0 again. And so 2 times 0 minus 0 is greater than 4. So is 0 greater than 4? No, that's false. So therefore, 0, 0 is on the left side of the blue line. So therefore, that was wrong. So now I'm going to shade the right side. And so where you see that black and blue kind of bruising color, that is every point in that region is an answer for that. And that's how you do that one. So, okay, what else do we've got? We've got 17 and 27. Let me quick jump to 27, and then I'll go back to the last one, which is the piecewise. So, how do you do writing an equation with 2 ordered pairs? Well, first of all, we're going to use point slope again, because I like point slope. And then number 2, you got to find the slope. You don't have a slope. Do you remember from Algebra 1 how to find the slope? You should. So finding the slope is y minus y over x minus x. I like to go left to right because that's me. So 4 minus 5 over 6 minus -2, which becomes a plus. So we're going to get -1 over 8. So there's my slope. Then to write the equation, you can pick either ordered pair. It doesn't matter. So what would be the better one to pick, though? No, it's a horse apiece. I picked this one. Why would that be a better choice? Yeah, because every time we have a negative, people go goofy. What did I do now? What? Oh, I wrote the problem wrong? Fudge nugget. Thank you. So that's going to change that. Okay. So now this slope got really nasty really fast. -9/8. Okay. So still yucky, but we can do it. So we're going to have y minus -4, so it becomes a plus, -9/8, and then x minus 6. And I'm going to distribute that out. So I'll have -9/8 x, -9/8 times a -6 would become a positive. Okay, so I'm going to have 27/4. And then I'm going to subtract 4. So y equals -9/8 x. This is really 16/4. So 27/4 minus 16/4 would be a positive 11/4. And that is the right answer. So that's how you do that one. And then the last one that you guys asked about with the piecewise, what you do is this. You write down all your pieces, and hopefully you remember we talked about critical points. So remember, we basically graphed by table. And so we want to pick numbers 0 and less. So you would pick the 0, -1, -2, -3, just enough to get a general gist of what that function's doing. This one, even though it doesn't equal 0, you need it, okay? Because it's still a critical point. So I want 0 and numbers higher than 0. So now when I graph this, we're going to plug this in just a moment here. So if I put 0 in here, I'm just going to get 2. If I plug in -1, I'm going to get 2.5. If I put in -2, I'm going to get 3. And if I have -3 in there, I'm going to end up with, that will be positive 3.5. So there's that piece. And then for this piece, that's a quadratic piece. So we're going to have 0 minus 2, which is -2 squared is 4. 4 minus 2 is 2. Then I'm going to have 1 in there. So that'll be -1. 1 will be 1. 1 minus 2 is -1. Put 2 in there, I'll get 0. 0 squared is 0. Minus 2 is -2. Put in 3, I'll get 1. 1 minus 2 is -1. So I have enough for a general just to get things going. So, okay, so 0, 2 in this first function is an equals value. So that's a closed dot. And then I'm going to have -1, 2.5, and then -2, 3. And so this is just going to be this linear function that's continuing on. And then for the other piece, technically this should be an open dot, but if you look at it, it's already closed because it was already in that other part. So you don't need to make it open now. It stays closed. And then we have 1, -1, and then 2, -2, and then 3, -1. And so then this makes this little hook piece that continues like that. And that's what your graph looks like. So any questions on your final? Anything that I didn't cover? I know it was rather intense. What? Good. So any other questions? Okay. So